the dot product of two vectors. I'd like to relate this to the magnitude of a vector. We've seen earlier that if you have two vectors u with component AB, then another vector v with component CD. Then let's say we have u, the magnitude of u is given by the square root of a squared plus b squared. Now let's square both sides to get u squared to be equal to a squared plus b squared. Now this is the same as u dot u equal a times a plus b times b. Now I refer to this as dot and this as times, because these are vectors and that is how we call them. Whenever we multiply them, we say we are dotting them. So we know that u has components a, b, then ab. So we are dotting these two vectors and the result is a times a plus b times b. So if we have u dot v, then this time we're going to have a b dot c d. So look at how the brackets went away. We multiply the s components plus the b components. So this time our u dot v will be equal to a times c plus b times d. So this is the definition of a dot product of vectors. Whenever we have two vectors and we dot them, this is the definition. So vector u dot vector v is given by this. Now this has an interpretation. It has to do with the angle between the two vectors. In other words, u dot v establish a relation between the magnitude of u and the magnitude of v and the cosine of the angle between them. But for now, let's just keep in mind that the dot product of two vectors has something to do with the angle between them. Now let's take an example. We have QP equal 3 negative 4 and QR equal 3 4. We are calculating QP dot QR. So we have QP vector QP dot QR equal to 3 negative 4 dot 3 4. So this will give us 3 times 3 then plus 3 times negative 4. So this will give us 9 minus 12, which will be equal to negative 3. Now let u equal 1, 4 and vector v equal 3x. Find x if u dot v equal 1. So if u dot v equal 1, then we must have, so we have u dot v equal 1. These are vectors. So we must have 1, 4 dot 3x be equal to 1. So by the definition of dot product, we have 1 multiplied by 3 plus 4 multiplied by x be equal to 1. So we have 3 plus 4x equal 1. Hence we have 4x. 4x is equal to 1 minus 3. So we have 4x equal negative 2. Then we have x equal negative 1 over 2. X equal negative 1 over 2. Perpendicular vectors. Perpendicular vectors have something to do with dot product. Anytime we dot two vectors, let's say we have vector A dot vector B, and we get the result to be equal to 0, then it means A and B are perpendicular, meaning that the angle between them is 90 degrees. So A is perpendicular to B. So I was telling you that a dot product has something to do with the angle between the two vectors. So these are examples of perpendicular vectors. We have vector AB with components 4, 3. Then vector, let this be C. Vector AC is having components, we have 1, 2, 3. So negative 3, 4. Now AB, vector AB dot vector AC will be equal to 4 by negative 3 plus 3 by 4. And this will be equal to negative 12 plus 12, which will give us 0. So this is because the angle over here is 90 degrees. Let u equal 3, 4 and v equal 4x. Find x if u is perpendicular to v. This sign means perpendicular. So if two vectors are perpendicular, then their dot product must be equal to 0. So we have u dot v should be equal to 0. Now we have our u to be equal to 3, 4. Then we have v to be equal to 4x equals 0. So we have 3 times 4 plus 4 times x equals 0. So we have 12 plus 4x equals 0. So we must have 4x be equal to negative 12, and we have x to be equal to negative 3.